Welcome back to this instructional video series. This video will explain the many new features of StruCalc 9.0. I will explain the features that will greatly enhance the usability and comprehensive capacity of StruCalc. We have worked very hard to update StruCalc 9.0 to the current code requirements as set forth in the 2012 IBC, including provisions for the 2012 NDS, the 14th edition of the AISC, as well as the ACI 318.11. We have also included the recently updated southern yellow pine stress values that were adopted effective June 2013, but were not included in the 2012 NDS. The printouts of your analysis, as shown here, will reflect these code upgrades. In StruCalc 9.0, we have added one new and exciting module to complement the other 11. This module is the newly revised hip beam module. It used to be concealed in the roof beam module. We have moved it over here, and we have worked very hard to greatly enhance its usability and accuracy by adding the option to include intermediate wall supports. You have many options in this specific module. You can consider full rafter tributary width in designing your hip beam, or you can consider half of the tributary width, or you can add an intermediate wall on either or both sides. As you can see, adding the intermediate wall will greatly reduce the load bearing on the hip beam, allowing for more flexibility in your design. One of the most significant enhancements to StruCalc 9.0 is the dynamic loading feature in the multi-loaded multi-span module. In this new version, you will be able to more readily see which span you are loading and also confirm that you are placing the loads at the proper locations. To start, I'm going to take this 15-foot simple span beam and make it a 3-span beam with a 12-foot length, a 15-foot length, and a 4-foot length. I will also make the 4-foot section a cantilevered span. Now I will place some random loadings on this 3-span beam. First, I will click on the left span indicator, and I will put a trapezoidal load on this span. I will start with 150 pounds per linear feet on the left live load location and 500 pounds per linear feet on the right live load location. Then I will indicate my starting point for this load as well as my ending point, and you will see my trapezoidal load appear. Next, I will put a uniform load on the center span by clicking the center span indicator, and then coming down here and placing a uniform load of 350 pounds per linear feet on this span. I will also put a point load on this span for good measure. Last, I will place 3-point loads on the 4-foot cantilevered span. I'll place the first point load of 200 pounds 1 foot from the left end, and then 500 pounds 2 feet from the left end, and then 1,000 pounds 4 feet from the left end of this span. This is a really useful feature as it shows exactly what you are adding as you are doing it. Then I can go down here and click on the loading diagram button and confirm that I've put everything exactly where I want it to be. We have also enhanced the functionality of the uniformly loaded floor beam module by allowing you to add a point load. And we have done the same for the roof beam module as well. Another really neat addition to the software is contained in the column module. We have added an embedded post feature which allows you to design a cantilevered column that is anchored into the ground or a concrete footing. StruCalc will help you determine the depth required per the provisions in the section 1807 of the IBC for both constrained and non-constrained embedded posts. Thank you for watching this video outlining our most significant improvements that we have made to StruCalc 9.0. We are very excited about the future of StruCalc, and we encourage you to share this software with your colleagues. Be sure to like us on Facebook. You can order StruCalc 9.0 by going to our website and clicking on the Buy Now button. You can reach us at toll-free 1-800-279-1353. We look forward to hearing from you.